composition of functions, notice the details in how it's written. What the composition of functions mean is you're taking one function and you're replacing every placeholder of another function with that entire expression. Okay? So if we take the same f of x and g of x, but here we take this f of g of x. Again, notice this is not x times g of x. Okay? No, that is different than f g of x. Okay? So those are two different things. When you refer to composition of functions, you're either going to see it in this form right here, where you have this placeholder inside of our x is going to be replaced with the whole function g of x. And you might also see it written in this way with a little open dot. This represents g of f of x. And so those are the two ways you're going to see this, the notation for composition of functions. And what that means is you're going to take your outer function. So my outer function here is the f function. So I'm going to take my f function, and everywhere there's a variable x minus 1, I'm going to leave just a placeholder. And that placeholder is going to be replaced with whatever's inside the parentheses, which in these compositions happens to be an entire second function. So my g function is x squared minus 1. So I'm going to place that whole thing inside there. And then I'm going to evaluate what's left. So x squared minus 1 minus a 1 gives me an x squared. Negative 1 minus another 1 is negative 2. So this would be the composition of functions in that form. Okay, now notice that this right here is the exact same thing, correct? It's just the other form of writing this. We take our f function first. The f function was x minus 1. We replace it with the entire function inside, the g, x squared minus 1, and that gives us our same thing. Again, no difference other than how it's expressed. Okay, I want you to try this second one. The second and third one are the same things. Yeah. What happens to this? So this is the x becomes a parenthesis. So when you're looking at a function, all variables in a function are just placeholders. It's placeholders for whatever happens to go inside the parentheses. So what I did when I set this up is I used a placeholder here. So I took x minus 1 or placeholder minus 1, and then I replaced the placeholder with whatever was inside my function, which was this whole g function, happens to be a binomial. All right, try the second one, taking the g of f of x. This one? Those two are the same. These are the two different ways to say it. So why is this one? So when you look at your outer function and your inner functions for these compositions, so here my outer function is f, and then the inner function is g. Here my outer function is g, my inner function is f. Outer function g, inner function f. Outer function f, inner function g. So what we'll do, and I'll go through some more examples of this to make sure it's clear. So if we took our g function is the outer function here. So the g function is x squared minus 1. Notice I didn't write the x, I left it as a placeholder, just the parentheses. And then I'm going to take whatever's inside my g function, which is this whole f function. It's a binomial of x minus 1. And I'm going to plug that in. And then I'm going to expand what I have. So my binomial square gives me x squared minus 2x plus 1 if I expand that out, minus this 1. So here the ones cancel, and I'm left with my answer of x squared minus 2x. And again, this is the exact same thing. I take my g function, x squared, placeholder squared, minus 1, and I replace it, the inside with this entire inner function, which is x minus 1, same thing. It equals the same expression. Okay, so let's say these are my two functions here. Right? If I wanted to take h of j of x, and this is probably the preferred method. This is the method I would normally use, but you need to recognize both. Okay, so the outer function is which one? So it's the h function. So what we're going to do is we're going to take our h function, which is 2 times x squared minus x plus 1. Notice everywhere there's an x, I just replace it with a placeholder, a parentheses. And then because my inner function, whatever's inside the parentheses is what goes inside these placeholders. It's an entire function, a binomial. So I'm going to replace 3x minus 4, 3x minus 4 for each of these. And then I'm going to evaluate it. I'm going to come back and evaluate those with a calculator here in just a moment. So what if I took j of h of x? Okay, so here I'm just going to set it up by hand. Okay, so here I take my outer function, which is 3 times x minus 4. Notice I used a placeholder for the x. And everything that is inside my function, this whole function h of x is what's going to go in my placeholder. So inside here, I write a 2x squared minus x plus 1. And I would evaluate each of those to get my simplified form, which I'm going to do next here on a calculator. Okay, when you do combination and composition of functions, okay, you can use a calculator to do it. We use y1 here, y2 here. Again, it can be whatever, however you enter it. But if I take my y1 function and I type in 2x squared minus x plus 1, and for my y2 function, I type in 3x minus 4. I can then go to my home screen, and when I evaluate these, h of j of x, h is my y1, so I'm going to type in y1 of y2 of x, close that off, and I get my answer, 18x squared minus 51x plus 37. Is it 37? Yeah. Okay, and so that would be my simplified form. And if I wanted to evaluate j of h of x, I would take my y2 of y1 of x, and when I evaluate that, I get 6x squared minus 3x minus 1. Okay, and that would be my second solution.